Welcome to Serial Tech. In this video, I will create a trigger that counts errors. So first off, we notice that the 10B error light is lit solid. What we do not know is if there are 4 errors per second happening, that will keep the light on solid, or if there are 4 million errors happening per second, for example. Anything more than about 4 errors per second keeps our LEDs on solid. So if we go to the trigger, we can count the errors. So the first thing we do is drag over an error event, go ahead and clear all the errors, then check those associated with the phi layer, the 10B coding errors, the disparity errors, the misplaced K errors, and then select a direction. And so right now we're concentrating for this first event on errors that are happening going from the initiator to the target, and then select for the action count per second, and then go ahead and label that. So I've got initiator to target errors per second here. Then, and this is where the mistake is most commonly made, we need to make sure to drag over in the same state. We need to create a second event group. So notice as soon as we drag in the second error event, we now have state 1 event group 1 that will count from I to T the errors per second, and then directly below it we have state 1 event group 2, and then we select from T to I, so from the target to the initiator, the errors per second. The rest of the trigger is identical. We clear and then select those errors that are associated only with the phi layer, and then we select the same action to count per second, and then again, so we know which side these errors are associated with, we go ahead and label it T to I errors per second. Now that this is done, another occurrence that will cause the error lights to light up would be check conditions. This is one event that covers both the from target to initiator or from initiator to target. We create a count per second, and it says here check conditions per second. So once all of this is done, we need to be aware that we now have in a single state 3 event groups. So these are all evaluated in parallel at the same time. Any event that comes in is going to be checked to see if it's an error in the phi layer going from the initiator to the target, or a phi layer error going from the target to the initiator, or a check condition. We want to limit the target to only those links that are active. Generally, we select 1 link. If you select more than 1, that's fine. Just be aware that if the trigger is monitoring links that do not have an initiator and a target pair, random errors and noise that are occurring on those lines will be counted as errors, and they'll throw off the count. So once this is done, we select Start Capture, and we see here that the counters are now counting in real time, updating approximately once per second the 10-bit errors that you can see here on I1. So you see the red error LED is lit solid for 10B errors, and we can see that, again, this could be just 4 errors per second, 4 or 5 will keep that LED on solid, but we see in fact here that we have over 100 million errors per second. So this indicates that obviously there's something fundamentally wrong with the calibration on the link that we can change to cause the errors to go away. Now, what changes you make vary from system to system, from setup to setup, and also by analyzer. I happen to be using we see now that the error light, the error LED is no longer being lit. So we'll go ahead and close these settings and then start capture again. And we see that now the error count is 0. So this is one way that we can use this error counting trigger. We can use it to test changes that we make to calibration to see which ones cause the least amount of errors or cause the errors to go away.